fascinating world of education. So I have a background in computer science from the US, and then I did my PhD in education in the learning sciences from Switzerland. And as I said, since last year, I've been here at NTU Singapore. So the agenda for today's session is quite simple. It's a two-part uh, session. The first part focuses on how can AI systems support teachers. And in the second part, I will showcase several very concrete examples of what we can do with modern AI systems for education. All right, so let's begin with the first part of the session. Now, I understand that using AI as part of your workflow may be intimidating at first. So let's just start by acknowledging the very real concerns that educators and people generally have about AI in the classroom. So there are cheating issues, right? We are all thinking of issues of plagiarism, unfair advantages, loss of critical thinking as students navigate with generative AI. There are also content issues, right? So with generative AI, right, there is always this possibility of misinformation and AI fiction. And so we need to have strong safeguards and emphasize critical thinking so that all of our students can learn to evaluate AI tools and responses, and they have an eye for misinformation. So there are cheating issues, there are content issues, there are also safety issues. Now, the safety issues focus on things like data privacy and misuse. And again, here, proper safeguards can help protect student data. Now, the idea that I want to share with you today is just like the calculator or the internet, AI is actually a completely game-changing tool that will transform education, whether we are ready for it or not. So ultimately, I think we will leave our students behind if we don't prepare them for the future of education or work. And of course, I understand that this can be a challenging thing for teachers and educators. So you might have noticed that the last 3 years has been a bit unusual in education. Teaching and education is a little bit different than it used to be. Of course, the pandemic accelerated the pace of change in education. And today we not only have, non-AI interfaces like Zoom, but we also have new software, which are AI-based software for things like grading and assisting teachers. And then we also have the more traditional AI for education tools like intelligent tutoring systems. Now, these changes are not completely new. If you notice in the last 20 years, the digitization of education has actually been happening for quite a while, but the pandemic just accelerated that pace. And so the question that we should ask ourselves as educators is that as each wave of new technology ripples through the society, how do we want to integrate it into our learning environments? So this was true with personal computers, then with the internet, and now with generative AI technologies. And for each of these technologies, there are many different ways in which we can integrate it into our teaching and learning practices. And these choices are critical, and they can have very different outcomes and implications. Now, the million-dollar question is, how should we make these choices? Right? So I'm not here to give you the answer to that question, but this is something that we should think about, right? I think we need to decide what kind of learning and education we want for our students, our children, our schools, our society, and then design new technologies and applications that align with these educational values and visions, right? So, of course, perhaps we can all agree that one of the top educational priorities is to develop young people as creative, curious, collaborative learners, right? Because these children or these students, as they go through our schooling systems and our university education, they will face a stream of uncertain, unknown, unpredictable challenges, right? And as these new AI technologies come into the picture, that may further cause more challenges in self-directed learning. Now, I want to start this talk by really outlining some concrete educational challenges where AI can help. So, the very first challenge is the global teacher gap. And actually, based on projections from UNESCO, it seems that an additional 44 million teachers will be needed by 2030 to fulfill this ambitious sustainable development goal of inclusive and equitable education for all. And actually, if we look at countries like South Africa, this is even more acute. So that's a problem, right? So we need more highly skilled, highly qualified teachers in our schooling systems. The second challenge, I think, where AI can support in some ways is the administrative and assessment gap. Now, perhaps as educators, we all realize that we spend a lot of our time not teaching, right? So even if we are passionate about teaching, we are passionate about talking to our students, a lot of our time is actually spent in administrative tasks, right? And so a lot of surveys actually say that only about 40 to 50% of a teacher time is spent teaching, right? And so if AI can help with automating some of those administrative tasks, then perhaps we can spend more time interacting with our students, right? Which is harder to replace with AI. So that's a gap. The third gap is a more um, economy focused gap, right? I call it the digital skills gap. And increasingly, there have been more and more surveys that talk about a lack of AI skills in the job market, right? And so we need more preparation, both for ourselves, but also for our students as they enter into the workforce, right? And again, AI literacy or AI education is a step in that direction. Now, Singapore, the place I'm coming from, has also prioritized personalized education in its national AI strategy. So the original strategy was launched in 2019 and it was revised in 2023, but personalized education remains a core focus. There have also been grand challenges in the field of AI for education. So the one that you see on the right-hand side is a call for research proposals to enhance mother tongue language learning for primary school students to increase their oral proficiency by at least 20% after 2 years. Now, within the National Institute of Education, we've quickly joined forces in starting the new AI for Education initiative. And it's actually a key growth area, key strategic growth area in Singapore. And NI is leading the way there. So I think one of the key takeaways from today's session, right? So even if you don't remember anything else, I think one of the key takeaways is there on this slide. So I think I want all of us to realize that good AI technology does not mean that that technology is good or impactful for education. So I call this, with the phrase good AI does not equal to good AI for education or AIED. So how many of you know of IBM Watson? Can do a quick show of hands with your virtual hands. How many of you have heard of IBM Watson? So IBM Watson was actually the computer overlord that won the Jeopardy challenge in 2011. So Jeopardy is this online quiz show, and Watson actually beat humans in Jeopardy. And that was a new era for AI because it signaled that computers could actually understand natural language, very much like we do. Now, the problem with Watson was that it was actually not a very good teacher, right? So even though it had very high natural language processing capabilities, it wasn't a very good teacher. It could not engage or motivate the kids. It could not inspire them to reach new heights. It could not keep the kids focused on the learning material. And these are all qualities of best mentors, right? So the key point here is that an AI tool or an AI technology that does not embody sound pedagogical models of learning is very unlikely to be impactful in education. Today, with the advent of generative AI, um, we have all these tools that can program very well, right? So generative AI shows very good capability to write programming code, and this capability is rapidly improving. So should we stop teaching our students programming, for example? I think that's probably not the case, right? Because even though these tools are getting better at learning to program, they cannot help students develop what we call code sense, or the idea of what is missing in a code and how to improve it, right? The conceptual understanding of programming. We can't teach them that through ChatGPT, for example, right? So instead, we want to combine probably the affordances of generative AI with good pedagogical models of learning to provide students with deliberate opportunities for learning. So good AI does not equal good AI for education. So today, there is actually an explosion of educational data, not just on learners, but also teachers and the process of learning. And as more of learning is moving online for many students, the availability of this educational data has increased manyfold. Now, this creates new opportunities to use that data to improve the quality of learning materials and to also improve academic outcomes and life opportunities. So today, when we speak of academic outcomes and life opportunities, we can think of them as 21st century skills that can very broadly be divided into foundational literacies. So that's the very leftmost column, the purple column. So things like literacy, numeracy, but then you also have skills like, critical thinking or creativity or collaboration. That's the orange bar in the middle. So these are competencies. And then you also have character qualities, so things like persistence, curiosity, leadership, and so on. And research in the field of AI for education over the years has actually shown that AI holds promise in helping students gain these 21st century skills. Of course, some to a greater degree than others. The World Economic Forum projects that jobs that will be created over the next 2 decades will require not just cognitive or technical or content-based skills, but also some of these 21st century skills. So students don't just need to learn efficiently, but they also need to be effective collaborative problem solvers and attend to these socio-emotional skills. At the same time, reskilling workforce will also be quite important. And again, AI Ed holds promise in including the latest work from the learning sciences to develop new tools and technologies to help students learn both in a personal tutor kind of format, but also as a learning companion, right? One challenge which limits the development of these socio-emotional skills is that we don't have reliable and valid indicators to measure these skills. And again, AI again can help us alleviate or mitigate this issue by tracking some of these skills or behaviors or competencies in a very fine-grained manner and collecting data from many, many, many students in how they exercise these skills, right? So again, with increasing emphasis on 21st century skills, I see a big, contribution that AI can make to help facilitate these 21st century skills in our students. Now, one important point also about this 21st century rhetoric is that there's a wide variation among countries. So if you look at this graph from the left to the right, you will see that there's a wide variation within countries that fall in the same income group. And if you look at this graph from top to the bottom, you can again see that there is big disparity among the income groups. What you will notice is that in the bottom right of the graph, so basically in the lower middle income or the lower income countries, the measurement and the facilitation of some of these competencies and character qualities is virtually non-existent. And at the same time, when you look at things like literacy and numeracy, the gaps are huge. So what this means is that we are failing to meet the needs of all learners. Globally, students from poorer backgrounds perform worse than students from richer backgrounds. Now, of course, we can all agree that all children should have at least basic reading, writing, and math skills, right? So if you see a gap in literacy and numeracy, what this means is that these folks will struggle with very simple everyday tasks, right? And that hurts their learning. So to tackle some of these achievement gaps in education, I want to give you a very quick example of the X Prize challenge, which was a technology-based challenge that was um, launched from 2014 or 2015 to about 2019. And this challenge actually encouraged teams from around the world to develop open source, scalable learning software that empowers children to teach themselves basic reading, writing, and arithmetic within 15 months. And what you see in the graphs are essentially pre-post gains in reading, numeracy, and writing, right? So just with very simple technology, right, students could actually achieve notable gains in their basic literacy and numeracy skills. I hope this example serves as a powerful demonstration of the impact that technologies, and especially AI-based technologies, can have in tackling some of the hardest challenges in education today. Within the field of AI and AI for education, there is new opportunity in part because of the use of interactive learning environments where students can do inquiry-based learning, for example. So on the left-hand side, you see a PhET simulation where students can connect two springs in series of parallel and determine the spring constant and spring forces and so on, right? So this is an inquiry-based learning environment. And then on the right-hand side, what you see is a game-like environment. Here, students can actually draw their own video game. So they can actually create or draw game elements, custom rules, music, and so on. So they learn coding with visual programming along the way, right? And they also have a fun and engaging learning experience. Or you can also have what we call intelligent tutoring systems in the field of AI for education. So I think this is the most classic type of AI technology that has been used in education for almost 30, 35 years now. So I want to describe very briefly what intelligent tutoring systems are. And then I'll give you a couple of examples of what these systems can do. So in very simple words, intelligent tutoring systems are adaptive instructional systems that can use AI techniques with educational methods, and they can customize the instructional activity for each student depending on their need, right? And every intelligent tutoring system, be it for math or science or writing or reading or whatever domain you can think of, has four basic components. So these are the four components that I show you on the slide now. I'll go through each of these components one by one. First, in the top, you have the domain model or the expert model. So of course, this is the knowledge that we want our students to learn. So this can be things like how to add or subtract, for example, or Newton's second law, causes of World War I, whatever, right? So it can be any domain content. So the domain model includes some representation of how experts think about a problem and what techniques they use to solve the problem. So that's the domain model. Then in the bottom, you have the student model. So the student model is basically any information that the computer knows about the student. So it could be the knowledge of the student, any activity that the student participated in, what their behavior is, what their prior achievement or difficulties are, and so on, right? And as students keep using the system, the student model gets updated, right, with every interaction that the student has with the system. What sits at the heart of any intelligent tutoring system is the pedagogical model. So the pedagogical model is something which brings in the knowledge of the pedagogy that is used inside the tutoring system. So one example of a pedagogy could be, the model of feedback, for example, that we want to implement in the system. So whenever students get something wrong, do we want to provide immediate feedback, or do we want to wait for a while to see if, students can actually come out of their struggles by themselves? So immediate versus delayed feedback, this is a decision, right? This is a design decision. And we can program that in the pedagogical model. So very simply put, the pedagogical model includes any theory of learning that a designer comes in with. So it could be models of feedback and assessment, for example. The fourth and the final module of an intelligent tutoring system is the user interface module. So this is really the front end. This is really what students will interact with, right? So the focus of the user interface model is on how to deliver information to students. Should it just be like a text-based conversational interface like ChatGPT, for example? Or should there be a pedagogical agent? Should there be a virtual character on the screen that students can talk to, right? So these are different, again, design affordances that one can think of when designing the user interface model. So these tutoring systems actually create large amounts of log data that represent everything that the student does during learning. And this leads to very large repositories of large scale data that are used by, hundreds of thousands or even millions of students per year. You see some examples of typical intelligent tutoring systems on this slide here. One of the weaknesses of these tutoring systems is that they have very little understanding of the context in which they are being used. So although they can track a learner's action in great detail, they don't really know about learners as people in the way a human teacher does, right? So right now, if an intelligent tutoring system, let's say, is being used for algebra in a classroom, it is actually currently part of the teacher's job to orchestrate the learning experience, right? Because the tutoring system does not really know all of the history of the student and all of their behaviors outside the online interaction context, right? So again, this is a very good case to think of how humans and AI can collaborate, right, in delivering effective learning experiences for students. So it's not just about using an AI technology, right? It's an AI technology plus a human facilitator who also plays a very important role. So one difference in the kind of data that was available, let's say 15 years ago, and now is that earlier data in education used to be very dispersed, very hard to collect, and small scale. But today, as I said, we have these large scale repositories of data. On the left is the PSLC data shop, which has more than 250,000 hours of students using these intelligent tutoring systems. And they have more than 30 million student actions and responses, right? So that's actually a lot of data to learn how students are learning, right? And can we offer them more scaffolds of support as needed? So in addition to intelligent tutoring systems, we also have other sources of data in education. So you have language learning apps like Duolingo, for example. You have all of these online courses like Coursera, edX, or Khan Academy, for example, where again, each and every interaction that you do while watching a video, for example, can be logged. And then you also have inquiry-based learning environments or interactive learning platforms like PhET and GoLab, right? All of these produce lots and lots of educational data that one can use to inform the design of learning. Now, if we look at these massive open online courses or MOOCs like Coursera or edX, they have actually attracted millions of students. But if you really look closely, their pedagogy is often less elaborated than the state of the art in education. So, how many of you have taken a MOOC on Coursera or edX? Can I see a quick show of hands? Please use your virtual hands so that you know. Uh, okay, so if you remember your learning experience in these massive open online courses, probably you spend the majority of time watching videos, right? Or you spend the majority of time, I don't know, like reading lecture notes, for example, or doing quizzes, things like that, right? And again, this is not to say that lectures are not a good way of learning, but probably we can do better in terms of designing learning activities, right? So the most typical activities in in these MOOCs include things like watching videos and so on, which although scale very well, right? Because you know potentially hundreds of thousands of students can watch the same video, all at once. So they scale very well. But actually, if you think of their pedagogical richness, right? Do they actually actively engage you? It's often not the case, right? So they lie towards the rather low end of pedagogical richness, especially if you compare them to other things like group-based problem solving, for example, which is a more active learning activity, right? So one key question in AI for education going forward is if and whether one-to-one or individualized instruction is the holy grail of education. If that is the case, are we sacrificing pedagogical richness by scaling up learning activities? So let's reflect a little bit more on the relationship between scale and pedagogy. In very simple terms, you can think of scale as the ratio of the number of teachers to the number of students, right? So let's look at this graph on the right-hand side. For very simple learning activities that fall in the top left of the graph, so things like watching videos or reading books or voting or answering quizzes, right? Um, if you scale them up, there's no loss in quality, right? So for instance, how much student X learns from watching a video or from answering quizzes will not vary that much if there are 10,000 other students also watching the same video, right? On the other hand, if you look at the bottom right of the graph, these are activities which are very hard to scale, right? So it's very hard to scale group-based argumentation in a class with 100,000 students, right? But we know that this is a pedagogically richer learning activity than making every student watch a video, right? So the question is, can we keep large class activities in MOOCs as effective as one-on-one instruction or one-on-one activities? So the counter question that I want you to think about is, how can we use scale as a pedagogical opportunity? We know that it's hard to scale up pedagogically rich learning activities. So let's say we are stuck with implementing video watching, in MOOCs, for example. Can we still reap some benefits with the data that we collect if there are 10,000 people watching the same video, even though we know that video watching is not such a great activity? That's the data analytics or learning analytics question in AI for education, right? So if 10,000 students are watching the same video, right, And we see that there are certain segments of the video where people pause a lot. There are certain portions of the video that people rewind and rewatch. If we see that there are certain portions of the video where a lot of people actually slow it down, right? Then we can begin to understand, what are places where delivery can be improved, for example, right? So even though video watching is a pedagogically poor learning activity, if many, many students are doing it, we can actually collect some data to see how to improve the video in future iterations, right? So in that sense, you can think of scale as also a pedagogical opportunity. Now, as I'm talking about individualized instruction or one-on-one instruction, so one tutor and one student, I must tell you that this has not been the sole focus of AI for education. And in the last few decades, the pendulum has actually shifted a lot between individual adaptation and social adaptation or group adaptation. So what happens when there are two students in front of a computer doing pair programming, for instance, right? How do we structure group activities so that people can argue and learn from each other's explanations and argumentation, right? So these are challenges which go beyond the individual learner. And then you need to think of how can we adapt or personalize to the group and not to the individual student, right? So the focus has always shifted between individual adaptation and social adaptation in the field of AI for education. Now, this discussion of the balance between individual and social adaptation also leads me very nicely to this very critical slide, I think, especially for educators and designers of educational technology, where I think it's important for all of us to recognize the correspondence between learning theories and AI. Actually, the birth of learning theories and AI are synonymous in some ways. So if you look at the very early developments in AI, so this is the 50s and 60s, that actually played a very important role in the development of cognitive science or cognitivism or the cognitivist field of thought. I think a lot of us might be familiar with cognitivism. So one key tenet of cognitivism is the acquisition metaphor, or the metaphor that the mind is a computer, right? And actually, this way of thinking about learning as knowledge acquisition, actually inspired a lot of the work, a lot of the research on intelligent tutoring systems. And this field of thought also talked about, cognitive load or the importance of mental effort that learners have to place when learning something. And how do we design for reducing cognitive load of students, right? So all of this is coming from the very cognitivist field of thought. But today, I think I would like to emphasize that learning as knowledge acquisition is only one among many other metaphors of learning. For example, you can think of constructivism, right? Which focuses on how students actively construct knowledge. Then you have situativism, right? Which focuses on how students become participants in a community of practice. So situativism assumes that all learning is social and it's actually distributed across people, tools, and artifacts. And finally, you have more recent perspectives on distributed and embodied cognition, which focuses on the role of the body in learning. So learning is not just about retaining information in your brain. It's also about using your bodies and engaging in sensory experiences, right, to learn something new. Now, why do I mention these different learning perspectives, right? So you might be thinking, this is a session on AI, right? Why give us a spiel about learning theories? I think I want to stress this because each learning theory has very different implications for learning technology design or AI technology design. And if we, as designers of these AI tools, do not really understand what these different learning theories have to offer, right, as is the case for a lot of ed tech today, that can result in suboptimal learning outcomes. Now, this stress on theory is also there in some of the most popular definitions of AI. So one definition that I like to, use in my talks is you can think of AI as any cognition method that is made to act independently towards a goal based on inferences from theory or patterns in data. Now, in the context of AI for education, the theory bit in the definition of AI actually focuses on what learning theory does the AI embody and implicate. So if an AI focuses on instructivism or the instructivist field of thought, then the goal of the AI would be to reduce cognitive load of students. And then the design of the AI would focus on things like, giving direct instruction, giving a lot of worked examples, for example, or giving instant feedback and explanations. But if the design of the AI is based not on instructivism, but on constructivism, then the design of the AI would focus more on challenging student understanding. The design would focus more on normalizing failures and feedback, or give students delayed feedback instead of instant feedback, right? So each learning theory that we come in with has implications for how we actually design the AI technology. And with each case, the design affordances will be different, right? And that's why it's important for us to understand, what these theories are and what that means for the design of AI tools and technologies. You will see in the definition that there's also the patterns in data bit of the definition of AI. Now, in the context of AI for education, patterns in data means any features that can help us diagnose the cause of student behaviors. And typically, we call that learner modeling in the field of AI for education. So if you want to know more about this topic, you can just search learner modeling in Google Scholar, right? And that's that area of looking at patterns in data. Now, within the context of AI for education, learner modeling focuses on any behavior that is observed. So if a learner is watching a video, at what moments do they click in the video, right? That's an observed feature. Then you have the inferred feature in learner modeling. So inferred feature would be something like, does the student seem motivated or not? Like, are they clicking through very often? Are they asking for a hint very often? And so maybe we can think of, they're probably bored or not so motivated, right? So boredom or motivation is an inference that we make from the raw data. And then we have also the rest of the learners who are interacting with the system. And so maybe we can predict something about the student based on how other students are using the system, right? So in the field of AI for education, we look at patterns in data from three different angles. We look at the diagnosis axis, which is the y-axis. We look at the history of the student, the x-axis. And then we have the social axis, which is the z-axis, which is what is the rest of the class doing, for example. And can we say more about the student based on what the rest of the class is doing, right? So a very simple example of this is that if you give an explanation and one student in the class does not get it, probably there will be five others who don't get it, right? So you can actually say something about the student based on these other students who don't get the explanation, right? So that's the social axis in learner modeling. So to wrap up this first, short segment, I want to just take you through the timeline of AI for education. And again, this is just, one timeline. You may have other timelines as well, but I think this one actually captures most of the important, moments in the field of AI for education. So if you start from the very left, from the 60s through the 90s, the focus was really on learning with AI. So how can we use AI-powered tools in classrooms? With the influx of educational data from the early 2000s and advances in capturing and analyzing that data using learning analytics, it became more important to also learn about AI. So learn about AI means learning about AI tools and technologies and techniques to be able to use AI in meaningful and ethical ways. And today, since the last couple of years, where we all have access to a lot of AI tools at our fingertips, right? Mostly based on generative AI. The focus has shifted from learning with AI and learning about AI to also preparing for AI, right? I think that this workshop that you're having falls very much under that preparing for AI, strand of work that's going on in the world, right? So we want all citizens to better understand the potential impact of AI on human lives. And for us as educators, especially, how it impacts our own teaching and learning processes. I wanted to do a small activity with you. I'm not sure if I can use the breakout room here. Could I quickly check with the organizers if I can do breakout rooms now? Would that be possible?
Sir, actually, we tried, but the technical team said we'll add these features tomorrow. In between the meeting, we cannot add this feature.
Okay, no problem. So I think in that case, I'll just walk you through, what I had planned for you, right? And again, I think as you go away from this workshop, perhaps you can, use this activity in a more, close setting amongst yourselves as well. So essentially, my plan was to give you 5 big ideas from education and from the learning sciences. And I wanted you to really think about how can AI systems support teachers in each of these 5 areas, right? So since we can't do the activity now, what I'll do is I'll just present these 5 big ideas, and perhaps you can all take notes on, what are some ways in which you think AI systems can support teachers along these areas. So the very first big idea is representations and support. And this is the idea that we want our students to make connections across multiple representations. So we want them to make connections across, for example, text, images, videos, simulations, animations, and so on, right? And if students can learn with these multimodal representations, right, perhaps they are better equipped to learn new concepts, right? So again, as you think of how AI can support, learning with multimodal representations, you can think of your own subject areas, and you can try to think of whether and how, without AI, how do you, as an educator, try to incorporate multimodal representations whenever you teach, right? Is your teaching heavily text-based, for example, or do you try to bring in, for example, relevant simulations or relevant animations, for example, to help students better understand the concept, right? So that's the space of representations, learning with multimodal representations. The second big idea in the learning sciences is collaboration, right? And this should come as a surprise to any of you. So essentially what it says is that learning environments should be designed to foster collaboration and help learners work together, make sense of challenging problems. So when you design learning activities that are group-based, for example, how do you orchestrate the learning activity? What are places where you see technology support can help as you design collaborative learning environments? The third big idea is how students think. So learning environments should not only focus on collaboration, but also focus on personalizing learning or differentiating learning based on different learning needs. Now, learning needs is something that you can define for your own subject areas, right? So one example is students who are struggling with learning certain concepts, right? How do you differentiate, what material you present to them, as opposed to students who are actually progressing at a faster than expected pace with their learning materials, right? How do you do it currently? Do you do it? If yes, how do you do it? And do you think when there are multiple factors that you can consider about a learner, how can technology help in helping you differentiate instruction better? So that's the space of how students think. The fourth big idea from the learning sciences, which is often underemphasized, is building on students' cultural and linguistic assets. Now, I once did a workshop where, I had a math teacher and, they said, I teach math, right? So, I mean, I really don't have time or the expertise to think about, building on students' culture, in my math classroom, right? Isn't this more suited for like a social studies kind of a classroom? And I was actually quite shocked because, there's more and more research in the field of learning sciences, which speak to building on students' identities as they come into a class, right? So a class is not just about, enforcing your ideas, right? It's also about understanding where students are coming from and building on their identities, right? And cultural and linguistic assets are important parts of it. The fifth and final big idea in the learning sciences is assessment and feedback. So how can we use, you know, or design AI tools and technologies to help us with better formative assessment of student learning? So typically, all of us, probably do summative assessments, right? So we always have the end of year exams, so the end of semester exams. But what about formative assessments? What about diagnosing students in their learning journeys throughout the semester, right? What kinds of data can we capture to better understand how students are progressing through the learning materials, right? How can you design or deliberately design these formative assessment learning opportunities? And what opportunities can be, outsourced in some sense to AI tools and technologies? And what can teachers take charge of, right? So again, that's a question to think of for your own subject areas and in the domains that you teach. So I think at this point, I want to pause for a 5 minute break, if that's okay. And then we'll, in the final 25 minutes or so, we'll do the second bit of the talk today, right? What can we do with modern AI systems for education? So let's take a 5 minute break, um, and then continue on with the session.
Right, sir. Meanwhile, I request all the participants to kindly drop their questions or queries related to the part of the topic just covered in the Dropbox so that we can take that in the end of the session as well.
Yeah, sure. All right. So I think I'll get started with the final segment for today. I hope most of you are back now. I can't
Uh,
see all
Sir,
of
just
you.
interrupting. Can we take the questions posted by the participants till now for the first part, or it will be taken at the later?
I don't see any questions. Can I see them?
Sir, there are two questions from Dr. Arun Kapoor. Arun sir, if you are available, you can unmute and tell your questions directly to Tanmay sir.
Yeah, sure. Because I can't see any questions.
Yeah, hi, good evening. It was a wonderful, thought-provoking and new information coming and a good presentation, very lucid. Thank you for that. My question was related to can AI transform higher education? Because most of the things you have talked about is very generalized, but I'm asking very specifically in higher education, higher professional education. And
Mhm.
my second question is, if it does have a positive impact, can you share some examples? You have a good experience of working in US and in Switzerland and also in Singapore. So can you share some examples where AI has shown to have improved learning outcomes in higher professional education? Thank you.
Mhm. Thanks a lot for the two questions. I think so. A lot of my work in the past 5 years, at least, has been in higher education research specifically, and so I can share with you a lot of examples. But let me pick like one or two which are most, probably most relevant. So I think one of the, I think it's a low-hanging fruit, is the implementation of chatbots, for our courses that we teach in higher education. And, today we have a couple of platforms where we can develop our own chatbots. These are free platforms, very easy to, develop these chatbots. And again, they can focus on the topic of your course. So just as an example, in my course last semester on AI for education for graduate students, so these are master students here in Singapore. I developed this chatbot, which was so the goal of the chatbot was to play devil's advocate as students brainstorm with it, for their ideas for the course project. And so every time students tried to, you know, propose us some ideas, the chatbot actually made sure to question them and ask them if they had thought through how that idea would be implemented, for example, right? And so across a lot of like higher education or tertiary education courses, the development of chatbots, for example, at least from the learning perspective, and also from the engagement perspective, right? It adds value to how we develop and deliver our courses. So I think that's one example. This has been made possible because of the affordances of generative AI. So 5 years ago, you would really need a lot of programming expertise to develop a chatbot, right? But today we can have chatbots which do fairly well, right? Of course, with all of their limitations, but I think it's still a value add-on in terms of students' learning experience. I think that's one example. One of the other examples is um, the use of AI to scaffold students' emotions during learning. So, I mean, we all know that learning something new is or learning something challenging, right? It's not a comfortable experience, right? It's um, it can be frustrating. It can evoke emotions like confusion or even anger. And so I think one positive use case of AI in higher education is to support and scaffold students in their emotion regulation during learning. So the focus of AI is not so much on helping students with the content, but helping students with these social emotional skills, and especially emotion, like emotion regulation in particular. So I think that's another example in within the higher education context. So I'm happy to share like some concrete references with you if you can follow up with me later. Yeah, but these are just two examples that I can think of very quickly.
So, yeah, we will share the information and probably I can have a better understanding on this. Now, when in the traditional way of education, the way as educator we assess our students and their performance and their final outcome at the end of a course versus a course which we generate with the chatbot and train them, educate them, and then do an assessment. Do we have studies in literature which do an audit? Which audit traditional teaching outcomes versus AI-assisted teaching outcomes in a cohort. One cohort is traditional, one cohort is AI-assisted, and then we get a concrete proof that, okay, AI is better off than the traditional method. Do we have literature which is published?
Yes, there are, but I don't think the evidence says, at least the evidence until now, says that AI-assisted teaching is always better, right? I think from a scientific perspective, I think the answer to that depends, right? It depends on how exactly is the AI tool implemented, for example, in a course, right? What are the affordances of the system? What are students doing with it? So it's not just about the tool itself, right? It's about the pedagogy also that comes in with that. So yes, there are studies like this, and again, I'm happy to share some studies around this. And there are a couple of avenues within the field of AI for education where these studies are often published. So actually, later I just have a slide on some of these researcher practitioner avenues for AI for education where you can find more of this kind of work. Yeah.
Right. Okay. Thank you so much. I think we can start with your second part.
Okay. So in the very limited time that I have, I will probably skip a few things, but still go through, some key things which I think are important to mention or worth mentioning. So I think this part of the talk really focuses on modern AI systems for education. Now, modern AI systems for education focus more on learning patterns and behaviors from educational data to achieve generalizable predictions. Now, this is very different from good old-fashioned AI, which is a very early approach to AI that relies on manually encoding human-right rules and knowledge, right? So today, I think some of the most prominent applications in education focus on how to track what a learner knows. So this subfield in AI for education is called knowledge tracing. When should we repeat material? Spaced repetition. So if you use Duolingo, right? Duolingo uses spaced repetition to exactly figure out which words you should revise when, right? When and for whom to intervene. So that's selective intervention. And then, of course, can we personalize this model to every student? And there are also new AI problems in content generation, for example. This has been made more possible with the affordance of generative AI, but work in or research in content generation has been happening for more than a decade, so it's not really that new. And then you have things like dialogue-based tutoring or digital or interactive textbooks and things like that. So let me give you, just a quick overview of some examples. So this is an example of content generation where you have the same base problem and you can generate multiple parallel versions of the problem that preserves the deep features of the problem, but changes the surface features, so that these problems can tap onto students' interests and perhaps motivate them better. So you see the same base problem can be represented with a Star Wars kind of theme or a cartoon theme and so on. Right? Then you have data mining for improving textbooks, which is also possible with generative AI. And one can augment these textbooks with real-world explanations, with solutions, with diagrams, with interactive simulations, and so on. And again, if you look at my reference, it's already a couple of years, ago. Writing assistance. So perhaps a lot of us have used Grammarly, for example. This is something a little bit more complex than Grammarly, which is intent-guided authoring. So given a context, like in this case, Sarah did not come to school today, with modern AI, we can actually give it an intent, like a cause and homework. And then the sentence completion is different for each case, right? And again, this is work which is pre-ChatGPT or pre-generative AI. Perhaps with generative AI, we can do this better. But I just want to use this example to illustrate that a lot of what is possible with generative AI, research on that has been happening for quite a while. So these are not really that new. It's just that we can now all use it, right? That's the only thing. There is possibilities of doing automatic assessment. Some of these systems have been used by companies like ETS for a long, long time. One very cool approach in assessment is called power grading. And this is the idea that, we can have AI that can look at answers and it can actually separate student answers into different subgroups, depending on, the kind of errors, for example, that students have made. And then as a human teacher or as a human facilitator, you don't have to grade like 1,000 student worksheets. You probably have to grade like 10 clusters of student work. And then, the system does the rest for you. So this approach is called power grading, where we group similar student answers, which correspond to similar modes of understanding in some way. And then teachers can just mark the groups, not individual students themselves. So this is also a very good example of human AI collaboration. So GradeScope is, for example, one system that uses some of these ideas of power grading. I talked about spaced repetition in systems like Duolingo. If we zoom in on the learner, we can actually figure out a lot more than just their current knowledge state. So we can ask questions like, has the student learned the current skill with the help of AI? What is the probability that the student has mastered a particular skill? Where in the learning sequence is the student? What have they learned before? What's coming up next? And again, all of these questions can be used to provide exercises or lessons or scaffolding at the right level of difficulty. With AI, we can also ask questions like, is the student wheel spinning? So is the student making no or minimal progress? We can also ask questions focused on the robustness of learning with the help of AI. So we can ask questions like, is the student learning to solve complex things that require inquiry or conceptual understanding? Will the student remember what they have learned? Right? As educators, we all ask these very critical questions. Now with AI, we can help augment that decision-making process. Is the student prepared for future learning? Is the student prepared to learn new skills beyond what they have been taught in the classroom? This is a very critical question for all educators, right? We want students to transfer their learning beyond the classroom. We can also use AI to ask questions like, how confident is the student? Are they asking for help when they need it? Are they persisting in the face of challenge? What's their affect? Are students gaming the system? Like, are they just trying to get better results without learning? Or are they being careless? Are they bored or confused, for example? Are they curious? So if we look at a lot of the algorithms for detection of emotions, AI algorithms, they focus not just on facial features, but they also focus on the tone of voice. So the rhythm of voice, the prosody, the vocal burst, and things like that. And we use all of these multimodal features to make a prediction on the emotion that is being expressed. Right now, of course, these systems are not 100% accurate. So we must be cautious when we use these kind of systems, in high stakes situations. Now, why is all this important? Like, why do we want to know if, a student is careless or a student is bored, or, what's the current knowledge state of the student? Why are these questions important? These questions or the answers to these questions have been shown to be predictive of end of year test results or who goes into college, or what college major students end up choosing, what's their first job after college, and things like that. So each of these features that AI can help us detect with some probability, right, are useful predictors for these important life outcomes or academic outcomes. So that's why we want to know about, this. And if AI can augment human potential, to help us answer these questions, why not? So now, let's say we know that a student is bored or, a student shows shallow learning. What do we do about it, right? What's in it for us? Within an AI system, we can offer what we call stealth interventions. So stealth interventions would be something like changing the difficulty of the next problem that the student is doing. So if a student shows a high probability that they haven't mastered a skill yet, probably the next question that we want to give them should be of a lower difficulty, right? So this can happen automatically with the detection of, whether the student has mastered a skill or not. We can also generate reports for different educational stakeholders, right? And these reports can focus on reviewing of the class material or discussing solutions with particular groups of students and things like that. And again, when we generate these reports, again, human instructors can deliver these reports, or we can have these interventions delivered by pedagogical agents. So on the screen, you see a couple of examples of what pedagogical agents may look like, right? So these are 2D or 3D virtual characters that can communicate with both verbal and non-verbal behavior. One of the big questions in the field of AI for education, as we collect all of this data on the student, is whether an AI model that we develop for a particular group of students, how well does it generalize to other groups of students? In particular, how well does the AI model generalize to students from different races or different national backgrounds or different genders and so on? And again, um, this is a hard problem to solve, right? So if you can think of, let's say, a predictive model that is designed for an online degree where most students are adult learners working full-time or part-time. If you develop an AI model for their learning, it's very unlikely that that model will be accurate for a residential university where most students are in their early 20s and studying full-time, right? The population is so different. So if you develop an AI model for one, you may have to tweak it quite a bit to get accurate predictions for the other subpopulation that you want to look at, right? Now, this is important because we understand that AI needs lots and lots of data to achieve high accuracy. But if there is a difference in the availability of that data, right, then it can lead to bias, right? And that's a whole problem area in and of itself within the field of AI for education, bias and fairness, right? So I really don't have time to talk about it, but that's, I think, a whole separate session all on its own. So I just want to show you a couple of research and practitioner venues as I'm wrapping up, just so that you can follow up with the latest that's happening in this area. So the 5 big societies that look at AI for education and learning are the Educational Data Mining Society. They have a conference, they have a journal. Then you have the International Society for AI in Education. Again, they have a conference, a yearly conference, and a journal. And then you have the Learning at Scale, which really focuses on data from big online courses, for example, or big university courses, for example. And then you have 2 other societies. One is the Learning Analytics and Knowledge Society that has a yearly conference. And that conference really focuses on analytics related to educational data. And that looks at the whole educational ecosystem surrounding a learning technology. So it's not just about mining data and analyzing the data, but it's also looking at, or the research in this area looks at how are these technologies situated within the broader learning ecosystem. And then you have the core society that looks at the problem of human learning, which is the International Society of the Learning Sciences. And over the last few years, there's been more and more emphasis on research related to AI for education. And you will find that a lot of the articles from these, places are free on Google Scholar. So, if you're interested in a particular topic from today, you can follow up, at these venues. So I think in a nutshell, I think there are a lot of challenges in the field of AI ed. One important challenge that I mentioned towards the very end is the generalizability of any AI model that we develop, right, to different populations. But then there are also challenges with respect to reinforcing and perpetuating societal biases when we develop these AI systems for education. With generative AI, a huge strand of work, research, is looking at over-reliance and loss of critical thinking, right? So as more and more students are using these generative AI tools and technologies, how can we actually prevent over-reliance on technologies like this, right? I don't have an answer to that, but that's a hard research question. There are also issues related to compromised privacy and unauthorized data collection, right? And as more and more of these AI tools and technologies are getting integrated into classrooms, there's also the risk of diminished student and teacher agency, right? And with generative AI tools, because they can produce a lot of false information and they can be confidently wrong about it, there's also the potential for misinformation, spread of misinformation. So again, these are all challenges that we have to think through as we design new technologies for education. But I think I don't want to end on such a sad note, because I think there are, a lot of benefits to actually infusing more AI in our teaching and learning. And really that comes from this potential of AI for differentiated instruction, both in the learning process, but also in the assessment, right? And both at the individual level, but also at the social level, right? I think more than half of our jobs as educators involves people skills, right? And that involves working directly with students. And, at this point, I don't see any evidence that tells me that, our jobs are going to be replaced by AI, right? So I think we are in a good place, but we're also in a powerful place where we can, meaningfully think through in how we integrate these AI technologies in a classroom. Remember, one of the key ideas that I shared at the very beginning was that good AI is not equal to good AI for education. So as educators, you must think beyond just introducing, let's say, ChatGPT in your class, right? It has to be something more than that, right? Which really brings out the learning experience, or which really improves the learning experience for students, right? So I want to end on that note. And just before I end, I have one more slide that I wanted to share with you. This is a list of relevant tools to enhance your teaching and learning. And perhaps I can share this slide, with the organizers later, who can pass this on to you. But I've put in a lot of free tools and resources that you can use, as you develop your own courses in the field of AI for education. So let me end on that note. And if there's time for a few questions, I'm happy to take them.
Participants, you can unmute yourself and ask your questions and queries.
Hello, sir. Hello.
Hello.
Yes.
Hello, sir. Hello.
Yes, sir.
Yes,
Can I?
you can ask a question. Yeah.
So my question is like, considering that some subjects are like, intrinsically difficult, assuming like, you're teaching computer programming to students. So are there any chatbots that are already available, or else like, are there any tools specific to like, teaching programming? Or can you shed some light on how AI can be used for teaching programming?
Mm-hmm. So I think um, maybe I will answer that question both from the pedagogical perspective as well as the technology perspective. And I'm sure you might already be using a lot of pedagogies yourself, but I think something that would be interesting is um, using AI generated code. We know that it's not always correct, right? We can use AI generated code and offer them to students to try and improve it, right? Or we can use AI generated code as opportunities for critique, right? So that's a very good use of not using, not developing a chatbot, for example, but actually using chatbot generated code in some sense and using that as part of your pedagogy. So that's one way of thinking about it. The other way is to actually develop a chatbot, right? And on the slide here, you see tools like, so if you go to the fourth point, you see tools like School AI, for example, or Mizo, right? These are free for teachers, and they can help you develop your own chatbots with very simple English instructions for what you want the chatbot to do. And you can actually share a very simple code with your students. And each of your students will have their own login, and they can engage with the chatbot. And you can actually specify how you want the chatbot to behave, right? So you can use like free tools like these, which are based on ChatGPT, to develop custom chatbots for your own courses. I think they're very easy to use and they're graphical user interface based, and you don't need any programming experience to develop chatbots there. You just need to type in a few instructions in plain English for how you want the chatbot to behave, what persona do you want it to have, and so on.
Thank you so much,
So I
sir.
hope that answers your question.
It was a great input, sir. Thank you so much. And your presentation was very excellent, sir. Thank you so much.
Sir, my question is, how can artificial intelligence be effectively utilized to enhance the efficiency and accuracy of academic or scientific research? How AI
So can you elaborate a bit more on
answer?
on
I want to ask that.
what part of the research process you're referring to?
As like, for example, sir, I want to do literature survey. Then how can be an AI be used for this purpose?
Yeah, so I think um, like 5 years ago, for example, right, when we did systematic reviews and meta-analysis, for example, we had to manually search through a lot of the literature ourselves and so on, right? I think today we have a couple of tools which can help you with literature search. I don't recall some names off the top of my head, but if you can write to me later, I can share with you some resources for AI tools that can help you do literature search. But again, the current stage of AI is such that you cannot rely on these tools completely, right? So they will only offload some of your work. So you will still have to look through and cross-check, whatever output has been produced with these AI-based tools, right? So that's the current state of generative AI. It's not as advanced as we may want it to be, right? But if you can write to me later, I can share with you some concrete resources for this.
Okay, sir. Thank you.
Can I ask you a question, please?
Hello, sir. Sir, is it audible, my question? Hello?
Yes, you
Yeah,
are.
please go.
Yes, sir. My question is in regarding to the AI technology. So how far it is so now it's competing with the human knowledge and everything. And moreover, what are the challenges we will face in future in regarding to the education sector and other solving of the problematic or human intelligence? And this aspect, can you explain it, sir?
Okay, so I think one nice way to talk about, the capabilities, right, is in
Yes.
terms of strong versus narrow AI. So strong AI is something that we saw in science fiction movies, right? So an AI that can do everything. It can play chess, it can water the plants, it can also talk with a human and so on, right? So that's all science fiction. We're not there yet. That's the goal of artificial general intelligence, to develop strong AI. But what we have today is weak AI, right? So AI that can do very well in certain domains. So an AI that can beat Gary Kasparov in chess cannot, empathize with a human, right? These are two very different skill sets, right?
Yes, sir.
So I
Yes.
think in terms of where we are dreaming of strong AI, but I think we're really creating a lot of specialist AI tools and technologies that are good at very isolated things, right? But if you think of human intelligence, right, we are often, good at many things, right? It's not just one domain. And of course, yes, we are experts in certain domains. So I think in terms of mimicking human intelligence, I think we're very far. One of the breakthroughs that happened though is that with generative AI, there is the possibility of creativity. This wasn't possible 10 years ago because AI can create new content, right? It can be very creative in how it presents its content, right? So again,
Yes.
you can argue if it really mimics how humans think of creativity. Maybe creativity in AI is something different than how humans think of creativity, right? So we aren't there yet, but I don't know what the future would be. But we are not there.
Yes. Thank you, sir. Thank you for it.
So, can I ask you a question, please? Hello.
Yeah, sure.
So, what we understand about AI, it seems that AI will bring down the cost of education. We currently, without AI, a lot of investment on infrastructure, recruitment, classrooms, lecture theaters, a lot of hardware, things are involved. So do you foresee AI bringing down the cost of education, say maybe 5 years from now or maybe 10 years from now? Number one. Number two, do you think with incorporation of AI in education, basic education, that is the school level, college level, do you think that more and more students who are underprivileged would be roped in if we use AI? So cost going down, more consumers entering and getting educated with AI with the help of AI tools. Affordability. What I mean to say is affordability. Less cost factor involved, hence more affordability at the user end. 5 years down the line, do you think we are heading in that direction?
Yeah, so I think that's an optimistic. Yeah, that's a very optimistic vision. I mean, to some extent, I agree that we will make education accessible to more subpopulations of students. But I think it also depends on what exactly or how exactly is the AI designed. So I give you a counter example. With all these generative AI tools, with every time we prompt it, right, that actually uses a lot of resources, both computational resources and financial resources and energy resources. So if you have 1 million students prompting, chat GPT style tools, actually the costs are going to be very, very high, right? And so can we afford this for long time periods, right? So maybe not, right? So it's not just about, I think, giving broad access to education for a very marginal increase in costs. That's, I think, one way of looking at it. The other way of looking at it is what exactly is the interaction that's happening between an AI and a student, for example. Is it taking a toll on hardware resources? on energy resources and so on. And so in that case, it's probably not that efficient, right? So perhaps there may be a better alternative to something like this. So I think it has both, pros and cons, I think, in terms of giving benefits to all. So I take a more critical view, even though, I do work on AI. I take a more critical stance on it.
Yeah, what I feel is that probably with AI entering more into everyday life and more, yeah, the next generation, the youngsters and the next generation to come will, if each institution will develop their own AI tools and the college institution, they make their own tools and they devise their own methods and that's how they deliver the education. They probably that will happen and it will become essential part of curriculum of every institute to develop, and institution will boast on their websites or wherever that okay, our institution has made so many AI tools. That will also be a point of competition, and in that way the cost factor will come down and probably more affordable. That's the very positive view I'm having. My next question is AI. What is the one is AI and then is HI, human intelligence versus artificial intelligence. What is where do they rank if they were to obviously they are competing. There are two competitors, AI and HI. As of today, 2024, which modality is a success, is better? Obviously, answer will be HI, but I'll take your thoughts. And in other words, what will be the failure rate? Human error, we always talk about human error. What is the AI error level? Is it more than the human error level or it is less than the human error level if we see on a comparative scale as of 2024?
So I think the tricky bit about errors in AI is that it can be confidently wrong, right? So it doesn't know the truth of what it is producing, right? So we call this hallucination in a generative AI context. So it can produce content that looks plausible, but it may just be completely off topic, or it may just be completely wrong. So it's very hard to judge the error rate. And I think error rate also depends on your domain of application, because an AI that is a good tool for, let's say, a computer scientist may not be a good AI tool for an education researcher or a psychologist, right? Because error rate depends on how we evaluate the conversations of AI, for example, right? So do we look at, let's take the example of generative AI, right? Here, error rate depends on, whether the AI produces content that is coherent, that is grammatically correct, that is natural sounding, and so on. So these are parameters to compute error rate for computer scientists, for example. But for a psychologist or an education researcher, error rate depends on whether the content that is produced by the AI matches scientific theories or learning theories, right? So the way we think of error rate, different domains or different disciplines will think of error rate differently. And so an AI that is good for a computer scientist may actually be a very bad AI for an education researcher or a psychologist, right? So if we now compare this with human intelligence, right, different subdomains will have their own perspective on it, right? But I just gave you one example of a computer science researcher versus a learning sciences or an education researcher or an educational psychologist. Like their views on what error means might be very different.
Sorry, I unmuted myself. So if we are talking about giving codes, like you mentioned that we can chat box code about what is the level of performance of a student. Okay, his AI code is this much, so it's faring better than another student whose AI code is this much. So in context to that, I was I was thinking about this question, like, okay, what is the error rate? That was a point of context I was asking about. If AI competency performance level is there, so there should also be AI error rate also. That is what was the
Yeah, okay. So I think in that concrete context, I think it's comparable or even better than human intelligence. So there are actually very recent reports from Stanford's human-centered AI lab, which establishes that, AI is actually is comparable or has superseded human level performance in a lot of benchmark reading, writing, coding tasks already. So it's already doing very well in some of these standard benchmark tasks. This is a very recent report from 2024, early 2024. So in that context, actually, it would not be human intelligence, I would say. But then the question is more for us as educators in terms of how we want to integrate that AI. Just because an AI can solve, the IIT JEE, questions, right? What does that mean for educators, right? So these are two very different questions. Just because an AI can achieve very low error rates in these very high stakes human performance benchmarks, um, that doesn't say very much about how we can use it in our educational contexts, right? So like these are two very, very different questions.
Yes, obviously, there would be some systems where there will be very critical systems, very sensitive systems like aviation industry or healthcare industry, where the scenario can be very complex. So application of AI will have its own hazard ratio, something like that. And industry like education, corporate world, hospitality, things like that, very less critical, not so critical. So probably implementing AI would be will fare better in those industries. So my thought, in context to how sensitive the system is and what are we applying.
I think even within education, though, I think there is this distinction between, different levels of AI risks, right? So you can think of how AI is integrated. Is it like human out of the loop kind of a scenario where the AI system makes all the decisions without any intervention from the human? Or is it more like a human over the loop or human in the loop kind of a system? So I think within education also, there might be some critical cases, like let's say we are dealing with students with special educational needs and we want to create personalized lesson plans for them, right? That's actually a much higher stake scenario than giving practice problems to students automatically. And in these two cases, again, one is definitely more risk, right? It's more high stakes. And so we would want humans to be really in the loop to oversee the AI's decisions and have the agency to make changes. But when suggesting additional practice problems, we can just keep humans out of the loop, because that's a more like administrative kind of a process, right? So again, I think within education also we can think of it on a case by case basis on what cases involve, keeping humans in the loop versus keeping them out of the loop.
Thank you so much.
Any more questions? I think there are no more questions, sir. We can conclude this session.
All right. Thank you very much. I hope this was a good use of your time. And feel free to contact me via email. You can find me on Google. If you have any questions or any, burning things that you would like to talk about, I'm very happy to talk to you.
Thank you, Dr. Tanmay Sinha, for such an engaging and informative session on AI for academic research and data analytics. Your practical insights in how AI tools can be used in research were truly eye-opening. You explained complex ideas in a way that was easy to understand, showing how AI can make research more efficient and help data analyze better and uncover new insights. We deeply appreciate the knowledge and clarity you brought to this session. Thank you so much, sir. Thank you once again.
Thanks a lot, and hope you enjoy the rest of the session.
Definitely, sir. Definitely.
Bye.
So, moving on to our next session, the topic is AI for personalized learning. It's my honor to introduce our distinguished speaker, Dr. Amit Prakash Singh, renowned academician and researcher with an extensive experience in artificial intelligence and its application in education. Dr. Amit specializes in creating AI-driven personalized learning solutions that address the unique needs of individual learners. His groundbreaking work focuses on adaptive learning systems that optimize research, teaching methodologies, ensuring students not only but learn but thrive. Today, Dr. Amit will explore how educators can leverage AI to craft personalized learning experiences, enabling tailored educational journeys for students of diverse capabilities and interests. Let's give a warm round of applause to welcome Dr. Amit. Over to you, sir. I think there is some network error. Dear participants, please wait until sir join with better connectivity.
Rahul sir, I guess there is some technical issue with the backend of Amit sir's profile. We'll just wait for a while. Sir will be there. Yeah, sir is here.
Okay. I have joined through mobile. Let me. There is some issue in my computer setting. Let me check it. Then I will be. I will be able to share this.
Recording in progress.
Please enable my screen sharing.
Sir, it has been allowed from here.
It is allowed, but host disable participant screen sharing.
Sir, you are co-host from our backend, so there might be not any issue regarding the same.
Let me check it.
Dear participants, you all are requested to fill the feedback form for the session 1. We have provided the link in that group, WhatsApp group.
Sir, am I audible?
You are audible.
Sir, can
And
you please...
just a minute. Mm. Oh, is it my screen is visible to all?
No, sir.
Not yet, sir.
Sir, there is echo also from your side. We have made you the co-host on both the accounts.
Yes, I have opened it through both the account. Let me enter with some other laptop. Please allow me to have a change the laptop. Okay.
Sure, sir.
Sir, by the meantime, can you please guide when we'll be getting the presentations and all for preparation for the exam?
Please pardon. We cannot hear your voice.
Sir, am I audible now?
Yes, you are.
Material for preparing for the exam, which is scheduled on the...
We'll
Get the presentations and
be
all.
providing that soon in the WhatsApp group.
Sure, sir. Okay. Thank you.
Thank you. Till we are resolving all the connectivity issues, I request all the participants to fill the feedback form for session 1 for day 2.
Hello, sir.
Yes, Ms. Dipali.
Yeah. So as per the schedule which was given to us, the topic for Dr. Tanmay was AI for academic research and data analytics.
Yes.
Whereas the topic that he presented was fascinating world of AI for education. The topic mentioned in the schedule was different, and the topic which actually was content taken was different.
No, the topic which Tanmay sir presented was AI for academic research and data analytics.
It is still disabled. Please enable it.
Rahul, sir, please make co-host for this new account being activated by Amit, sir.
Shyamli Singh Diamond.
Done, sir, done. Amit sir, am I audible?
Yes, yes.
Sir, you can WhatsApp the PPT to me or to Vidhi ma'am or any of the.
That is the best.
We can play that PPT from here, from our end.
Already WhatsApp to Sweta, but let me. Vidhi is there,
Yeah.
so let me send to the.
Yes, sir, please.
I have sent to Vidhi.
So we are playing that PPT in a while.
Okay. Okay. Sorry for delay. Am I audible?
Yes, sir, perfectly fine.
Good. So let me first thanks organizer of the event from Chandrababu Jain College group of institutions for conducting ATAL sponsored faculty development program on AI for teaching learning purposes. And one of the most interesting topic has been given by Dr. Sweta to me, that is AI for personalized learning path. So recently I have attended and I have seen last slide of the previous faculty, previous speakers, who has given some list of tools which are available for the teaching learning purposes. And it is a very comprehensive slide which I have seen in the last minute. And he has given about the list of tools which are which can be used for the teaching learning purposes, which are optional for various popular chat GPT sort of tools. So now let us first understand what is the meaning of personalized learning path. The sentence is very much important because when we talk about the personalized, it means that here our objective is to take the help of the AI tools for the development of individual skills. Individuals means that individuals may be students, individuals may be faculty member, individuals may be the research scholars, and everyone has their own way to learn the various skills, and everyone has their own pace to understand the technology. Everyone has their own ambitions, that how do you want to use the AI tools for your academic purposes. There are different types of people in the faculty, in the society, where everyone has their own requirement to understand the subject. Let's take the example that a student of the education who is pursuing B.Ed program and with a specific subject like mathematics and science, even though those are the two subjects which the students have chosen based on their academic curriculum. But because of the interest in other subjects, the faculty wish that those subjects would also be considered for his or her career. So the science students may choose English as another, that is called personalized learning path. The subject which has been chosen by a candidate other than the course curriculum is the personalized learning path. Now the question is, if a candidate has chosen to learn the English subjects, so how to get the expertise knowledge of a specific subjects? So to achieve this objective, there are few tools which are available with the help of the AI. That AI techniques will help the candidate to choose the specific path. That is a AI for personalized learning path. Please, next slide. Okay. Now to achieve this, to achieve this, various verticals are required to understand. So to achieve a specific objective by a candidate, the candidate needs a few information regarding the content. Then how and what are the other users available in the world? Then personalized learning methods, various personalized learning methods are required to be adopted by the candidate. So these are the various verticals which we need to understand, that the AI, how AI will help a candidate to choose the content, to get the feedback of the learning, what is the learning has been completed by a candidate, how a tools can engage the candidate with a multiple workshops, multiple questionnaire, multiple FAQ. So these are the things which we need to take the help, with the help of the tools which are powered by AI algorithms. So all the techniques recently, like in the last slide of a previous speaker, who has mentioned a few tools. The purpose of these tools is to enhance engagement, to give more skills relevant to the particular subject. So this is how AI will help to the candidate to choose the appropriate learning path. So let's take the example that how the content recommendations will help a candidate. What is a content recommendation? The question arises that what is the meaning of the content recommendation? So content recommendation is basically developed by a particular tools with the help of some sort of a artificial intelligent algorithms, which will find out the relevant subject material available in the World Wide Web. So basic purpose of the particular algorithm is to find out respective materials. So how to find out a specific material? In the previous example, which we have considered just now, the candidate belonging to a science stream studying in a B.Ed program, then how the candidate will choose the English. So when the candidate has chosen the English, which will help him or her to shape the career in a better way, the candidate need to find out some literature which literature will help the candidate to get the knowledge of a grammar, of a literature. Literature, again, this is the subject which is a very vast area. The subject like English may have a historical value which comes from Europe, and it goes to the American, then Indian, Asian subcontinent, and so many things. So every places, everywhere, the fundamental aspect of any subject needs to be find out. So this process will help the candidate to choose the various subjects which can be taken up step by step, so that the candidate can learn the specific subjects. That is a content recommendations. So similarly, when students started content recommendations, the candidate also needs to have some interaction with some similar type of people. So there is a requirement of a platform where similar type of people are also working in the similar area. So that is another feature of a particular tool, and many tools are available, like one of the very popular platform which is available in the blog site, that is a Quora. Then there is a GitHub for the technical people. So there are tools which are available with a specific background. Like if you will take the example of the GitHub is the platform where technical person can understand the communication between them. But Quora is a platform where non-technical person can also communicate with a peer group and get the answer with a similar type of feedback. So this is the tools which we need to understand, that which tools are better for specific subjects, and those tools will help us to shape the personalized learning methods. Then skill development. Skill development is the most important part in any person for shaping the careers, because when we talk about the skill development, it varies from the person to person as per the requirement. If you are talking about the here, like at present we are talking about the AI. So the question is that for the non-technical person, AI is the tools. But for the technical person who are working in the area of the computer science, they cannot use AI as a tool, but they want to write a program where AI algorithms should be implemented. So there is a fundamental difference between the skill development, that what type of background the candidate is having. If a candidate is having a background of the computer science subjects, then it is the responsibility of the candidate to write a programming, any of the programming language. While in the case of the non-technical persons, normally non-technical persons uses this type of tools for the analysis purposes, for the learning purposes, for the development of the better analysis of a specific paragraph. There are tools which are available in the various domain, where you will find that summarizations can be carried out. You enter the 100 line of codes, 100 line of text in a particular window, and the tool will summarize the keywords and reproduce you. That is called the summarization technique of the particular text. So these are the AI tools which are available, and we need to explore various AI tools with the help of the various prompt. So this is very much important, that we should identify that what type of tools which help us to shape our career. Similarly, whenever any learning path is there, there must be a provision for the real-time feedback and engagement. Because when you start working on a specific tools, it is important that how the tools engaged you with a specific FAQs, with a specific questionnaire, so that candidate uses his or her mind and apply and brush up the things, that how a specific thinking process can be developed. So this is how various verticals are required in the AI tools. Then only the AI tool that particular tool can be known as the AI tools. Same, now another important part is the real-time feedback. That the question is that what is the mechanism for the feedback process? Here feedback means that the candidate who is studying some aspect, some theory, then it is important that we as a tool, it is the responsibility of the tool to find out that what is the learning capacity of the candidate. The learning capacity of the candidate it can be carried out with the help of some sort of a feedback process. The feedback may have a questionnaire, may have a multiple choice questions. There are some sort of a things which should have a real-time impact, that immediately you answer 5 questions and some answers should be available, so that the understanding of the particular subject by a candidate can be carried out. Because nowadays most of these type of courses are available on a self-paced basis. So when we talk about the self-paced courses, it is important that there must be a system, and you must have seen, if you have ever seen any self-paced courses like EduX or Coursera, they have a mechanism that you learn this much slides and this much lecture, prepare your assignment and upload it, and then can take the assessment test. So once you qualify that assessment test, then only next module will be enabled. So this is the better way of having a AI based learning methods. Next slide. Okay, so when we take about we decided that the personalized learning should be carried out. So there is a aspect that how to move further, that what would be the learning journey process. So learning journey process is a very critical part, and these are the some parameters or some of the topics which has been published in one of the research article. Yes, these are the some research article. So in this case, it is categorized as data gathering, AI analysis, creating learning journey, executive learning journey, and feedback. Now, this is the objective of this parameter is that how AI tool helps you, because AI tools has a basic objective, that what is the methods that how they collect the data from a candidate, then only it will decides the learning path. This is a similar way as we talk about when we discuss about the progress of a candidate in a particular syllabus or particular subject, that how the candidate progress, what is the outcome of a particular subject. So those data are normally stored. We do it in the various parameter, like if students gets all the marks, full marks, then we categorize it as a excellent category. And then if a candidate fails to get the 50% marks, then we categorize the candidate as an average. So with the help of this data, normally what happens, the teacher has got the view that what is the capturing capability of a students. Similarly, data gathering is the parameter which we need to assign in there must be a data gathering methods in the AI tools, so that various, like a candidate who has attempted module 1 and completed that module 1 in 10 hours. That is the another other attributes of a data. Then if a candidate completed module 1 in 10 hours and got the assessment marks as a in the average category, like 60%. So these are the very important parameters. The AI tool should understand that if a candidate is devoting 10 hours in module 1, normally module has also some level of difficulties. And if that has been labeled like the module 1 is a, let's take the example that module 1 is an introductory module. It means it is the elementary level. There are normally in the online modules, there are intermediate module, then preliminary module, then difficult modules. So there are 3 categories. So all these value or the weightage of the module along with the assessment marks, along with the time devoted to learn a specific module are required to be calculated, and basis on this the candidate will be awarded a appropriate weighted marks, not a direct marks. The candidate may got average marks in the introductory module. It means that overall the impact of that module is less than 50%. So this is called AI. AI is never a straight answer. AI never give you the straight answer that X plus Y is equal to Z. If there is a X, then AI should have that AI tool must have a consideration that X is multiplied by what factor. If the factor is strong, and if then only the appropriate weightage will be given, and accordingly the result of Z will be calculated. So this is why data gathering is one of the most important part in the AI based tools and techniques. Whenever you are using any AI tools for any computation, please keep in mind that it's not a straight answer. AI means that some sort of a knowledge repositories are used for calculating the data analysis. That is why AI analysis is a different than the data or mathematical analysis. Otherwise, if we state, because in the mathematical analysis, if some data is given and if you are performing mathematical operators, then mathematical result will be presented. But in the AI analysis, no data can be calculated on the basis of mathematical operations. Every data are required to be computed with the help of a mathematical operation along with the feedback operations. So when you apply some feedback methods, it means that there are mechanisms to attach some weight against a specific result so that appropriate analysis can be carried out. Because why it is important, the purpose of the AI is to predict the outcome with the help of some unknown value. So even though there are some unknown inputs, but the AI have a capability to present, to provide the outcome based on some unknown value also. So how that unknown values are replaced, the approximate value of the unknown tuples or unknown attributes are calculated or inferred with the help of a appropriate algorithm through their knowledge repository systems. So knowledge repository is nothing but it is a data gathering. So data gathering and AI analysis is one of the most important part in any AI personalized learning journey process. Then it comes to the candidate, that how the candidate can use these methods for their personal growth or personal learning system. So those are helped with the help of the learning methodology that is called either executive learning journey or creating learning journey. So this learning journey is the important aspect, that how a person's or a candidate chooses their subject in such a way so that those subjects help you to make the journey appropriate learning way. So this is this particular journey path are calculated with the help of the content recommendation system. So that is why there are learning journey which are connected through the content recommendation systems. So content recommendation systems help the candidate to identify appropriate learning material so that the learning path can be carried out. And in the last, assessments are carried out with the help of the feedback gathering. So basically, the assessments can be, as we discussed, that it can be questionnaire, it can be assignment, it can be the project reports. So those are the various parameters which allow a candidate to get the personalized learning journey. Next, please. Okay. So in the same sequence, this is how we were discussing that how content recommendation systems help to find out the adaptive assessments. So you can see it there that there are same things. Now the question, whenever we talk about the personalized learning path, the only important part that how the content recommendation system should be developed. In the content recommendation system is the most important part in the algorithms, and large number of people are working in the area to find out and to develop the better algorithm so that content recommendation systems can be implemented. So there are large number of recommendation system. You can even in the computer science system there are people who are working in the recommendation system. Recently, one example is there. This Amazon has implemented the recommendation system that if you purchase one product, basis on the category of that product, the recommendation system, Amazon recommendation system will help you to recommend you that you purchase another product of a similar type. The examples are right. If you are choosing a bread, so normally bread comes into the category of the breakfast items where butter and egg, jam are also placed in a similar group. So if a candidate is purchasing a bread, then this Amazon sort of a system or Zepto type of a system, they recommend you some similar product that you may purchase this, or this many people nowadays some another way the influencer are writing that this many percentage of people have purchased the butter also along with the bread. So this is how the recommendation systems can help you. If you are asking that the best literature to learn the British English, so or best author to learn the English literature. So if you are asking this type of questions, then naturally the recommendation system, one way is that Google search is not a recommendation system. Keep in mind, it is a normal search mechanism which search the content with the help of text. But nowadays they are also applying some sort of a recommendation algorithms where they will provide you some specific information that these are the few authors who have worked in the similar area. So this is the power of the content recommendation systems. And basis on the content recommendation system, the assessments are carried out, because most important part in any learning path, whenever you talk about the personalized learning path, most important aspect is that what is the percentage of the success of a candidate. So that percentage of a success of a candidate are carried out with the help of the assessment. So assessment is a one part. Here we are using the term adaptive. So what is the meaning of adaptive? Basically, adaptive means that the weight, the associated weight, because every questions cannot carry the same level of difficulties. So it means that AI tools should prepare some sort of a assessment tools, techniques, some sort of a questions where a appropriate weight must be associated. So depending on the difficulty level of a particular questions and the question being replied by a candidate, the weightage of a marks should be given basis on that assessment methods. That is called adaptive assessments. It is not a straightforward assessment, but it is the weight related assessment. Then third parameter, which is normally available in the AI tools, that is called real-time feedback. It is related to the adaptive methodologies, but real-time feedback, that how do you choose the various questions, that on what basis the candidate can be asked to give the feedback, or on what basis the candidate can be asked to get the assessment. So this is how the feedback process and assessment process are two output from a AI based personalized learning methods. And there are large number of learning management systems which are available commercially or academically. There are also some of the tools are available free of cost also. Those tools help the candidate to use the AI technique in a better way. Please, next slide. Next slide. Okay. So the question arises that what type of a recommendation system? What are the various component of the recommendation system? So if you categorize this, one of the category is read by end user, similar articles, and recommended to end user. Now, let's take the example here. That I wanted to study the literature of the Shakespeare. And I have been asked to write a research article on the various dimension of the Shakespeare. So it means that I want to know that which article are important article of a Shakespeare. So there are two ways. One way is the find out the article of a Shakespeare which are cited most. So which are having a highest citations. This is the one way. So there are few tools which will help you to find out the most citation of a particular type of a article, whether author wise or whether based on the various subject. Second search involve similar article, that you are asking, you are talking about the literature on Shakespeare, then what are the various types. So you will see that there are large number of and then articles are available which are published, which are indexed. Now through the various filter, you will be able to reduce your search in such a way so that download those articles only which are relevant in a particular year. Because once you read the most cited article means that most of the author have read the particular article and they have also cited that article in their publication. It means that the particular article has some weightage, some value. So the article should contain some important material, some information. Those informations will help you to find out similar article in the area. So that is a content recommendation area, a system. So this is how the content recommendation algorithms are implemented and designed, and then it will recommend to the end user that these are the top 10 articles which are useful in a particular subject, and the candidate can use this article to read and prepare the analysis. So this is the one of the example to develop the recommendation system or in the algorithms basis. Next slide. With the next, yes. Second aspect of the benefit of the personalized learning. What is the benefit? Why do we are encouraging a people to use the personalized learning? So these are the various components which are listed in one of the research article, and it is called enhanced engagement, then improved learning outcome, skill development, challenges and ethical consideration, bias. What is the meaning of individuals? Points, let's discuss about that. So when we talk about the enhanced engagement, so engagement is a very key term. And when we talk about the engagement, it means that we are talking about that how the tool will help us to get the engagement in a or to get the information of a specific content, so that it will help us to engage in a better way. So this is how your content recommendation system help us, because when we talk about the engagement, it means that here we are talking about that various self practiced questions, self-practice answer, then some sort of a computation, some sort of a game. There are few tools which are available with games also. Like there is one example of the AI tools in the area of the climate change. So there are few people who are there who develop the some sort of a game. They train the model to explain that what is the impact of a global warming. So they explain with the help of a temperature, that you click in the particular button, there is some sort of a temperature increases. Then how the increase of the temperature will impact on the glacier. Then if some volume of the glacier, if some sort of a glacier melt, then how much water will flow. So these are the computational things, and this is nothing. It is the enhanced engagement of the tools. This is how we state that enhanced engagement help us.
सिचुएशन है जी, जो आदमी 11 बजे आ रहा है वो 7-8 बजे जाता अच्छा लगता है। आदमी यहाँ 9 बजे आ जा रहा है और फिर उसके बाद फिर 9 बजे 10 बजे आ रही हूँ, तो इतनी लेट पे जा रही हूँ, तो कैसे दूसरों के साथ में बदलूंगा? मैं तो लेट आने
Apologies for the same. I request all the participants to kindly mute yourself till the session is going on. Sir, you can unmute yourself. Apologies.
Okay. So second question is what is improved learning outcomes? So when we talk about the improved learning outcomes, if anyone have ever seen the teaching learning processes, So the learning processes are normally measured with the help of an outcome. There are outcome are mapped on the basis of the course outcome and program outcome. And every outcome are given some value from 1 to 4. If a course outcome or a specific topic, let's take the example, then in a specific CO1, course outcome 1. Course outcome 1 is, if it is mentioning that introduction of a Shakespeare literature, then introduction of the Shakespeare literature is the understanding is that what is the level of the outcome the candidate achieve. So if a candidate achieve good assessment marks, then it is called the better learning outcome. There is some good assessment methods through which the learning outcomes can be measured, so that the improvement in the learning outcome is also required to be measured with the help of a appropriate mechanism. So these are the some tools and technique which are required to be incorporated in the AI tools. Then third parameter is the skill development. Skill development, again, people should know how to write a prompt. If let's take the example that there are persons who are using ChatGPT. So ChatGPT or similar type of a environment will provide you the various answers. But the question is how you are writing a prompt so that the appropriate answer must be available. The prompt should be written in such a way. It should not be very much specific, but it should be a generic, but it should have a clear understanding that how to achieve that particular answers. And most important part is the ethical considerations and bias mitigations. Because whenever a candidate chooses the path of a personalized learning, that it means that the candidate is using large number of AI tools and technique. So when you are using the AI tools and technique, AI has a capability to fetch the content from already published work. So how you will maintain the ethical issues with a specific topics. So these are the challenges, and these challenges should be met out by the candidate with the help of some scope, some limitations, and it is always better to have to use the AI tools for the knowledge repository, but it is not recommended that you reproduce the content as it was published. So this is the very fine line that how you chooses to reproduce the content, because to read the subjects to gain the knowledge is a different part. But if you start reproducing the subject, then it comes under the cases of the ethical issues, and those things should be avoided. Next, please. Okay. Now, keeping in view of this personalized learning path, the Government of India has introduced National Education Policy 2020. And this learning path is nothing but it will help us to get a curriculum and pedagogy in schools, learnings in holistic way, integrated, enjoyable, and led. So basic objective of the personalized learning path is nothing but it is if we fulfill this learning path in our course curriculum, and if we allow a candidate to choose the subjects, then automatically those skills, those introduction of the subject will fulfill the requirement of the national education policy of this country. In the NEP, they specifically mentioning that the curriculum should be made in such a way so that it should contain the essential subjects, skills, and the capacities. It empowers the students through flexibility in course choice, holistic development of the learner. So these are the basic objective of the new education policy. And if we chooses the personalized learning path, this is nothing but it provide us to get the courses as per our choice. So because in any educational institutions, it is difficult to provide all the choices or multiple choices to the student. But in the changing scenario, when there are large number of online platforms are available, where they are containing all these attributes. They are containing the assessment tools, they are containing the content recommendation systems, they are having a different types of real-time feedback methods. They will allow us to shift our academic system from a limited subjects to the personalized choice. And it will also help us to develop our own mark sheet. That is the best part. If you allow a candidate to choose and prepare their own course structure with a flexible environment, this is possible with the help of the AI tools and techniques. In fact, recently, UGC has also adopted the same concept by proposing to pursue 2 academic programs simultaneously. That is nothing but it is the similar type of things where the candidate can develop their own personalized career systems. And this type of tools and techniques helps students to get the better skill based subject, having an engaged model, having a holistic system, having a interest, the faculty or the candidate who are interested in a specific subjects, they learn the things with the help of the personalized course and curriculum. Next, thank you. Next, thank you, and it is over from my side. Any questions, you may carry on.
Thank you so much, sir. May I now request the participants, if anyone is having any kind of query, you can ask the same on the forum.
So it seems now things people are getting it, and my email is also there. So in case of any interest of any students or any candidate, they may contact me. And let me thanks to the organizer for inviting me for delivering a talk in ATAL FDP. Thank you.
Thank you so much, sir. It was a wonderful session. Hope everyone has taken a good knowledge from this. And we will let you know if there is any query post this session, and we'll keep you updated with the same.
Okay. Thank you
so much. Thank you so much, sir. Thank you. Thank you, participants. We'll see you tomorrow with the next session of the FTP.
Thank you, madam. Thank you.
Welcome, sir. Good night to all.